Hello and welcome to BioGill's webinar number 2 leading into WEFTEC 2017. My name is Nick Watkins. I'm the Regional Manager for APAC here at BioGill, and today we'll be taking you through some of the juicy parts of BioGill Company, case studies pertaining to our applications in food and beverage and sewage treatment projects. Before we get started, just a brief agenda and some introductions. Along with myself today, we also have Annie Wydert, who is the Regional Manager for the Americas at BioGill, and Dr. Steve Gluck, the Technical Advisor for BioGill USA. Today's agenda is as follows. We'll go through a brief technology overview and recap for those of you that may not be familiar with the company or who missed our first webinar, and then we'll be diving in specifically to some case studies pertaining to brewery, candy or high sugar manufacturing, RBC wastewater treatment upgrades, and winery projects. I'll now pass the presentation over to Steve, who will explain the technology, how it works, and why it is unique.
Thanks, Nick. We'll first take a look at the cutaway diagram of a BioGill tower, as we call it. It's about 7 feet tall and 4 feet square. Influent is dispersed across the top of what we call gills and flows down the gills, collected at the bottom and goes out the effluent at point number 5. Air comes in at the bottom, labeled number 4 on both sides, and goes out the top, also labeled number 4. The driver for forcing the air through and out is not motorized or anything. It's just simple convection by the chimney effect. Now I want to draw your attention to the circle in the upper left-hand part of this diagram as we go to the next slide. On this slide, where it's blown up, the part in the circle, I've shown 2 gills. If you look at them, they're flat sheets of fabric coated with a nanoceramic material that just loves biology to attach to it. The fabric is supported much as if like a curtain over a rod where you would see air side. That rod is not shown and drops down. Water flows across the top of the gills as it's dispersed and then down between them, shown in blue. Biomass, shown in brown, immediately begins to grow on the gill surface and through the gill to the other side where the air comes in. Now there is a minimal structure which holds these gills open on the air side to allow air to freely flow in and out. Thus, oxygen transfers from the air side through the biomass to the water side, promoting a diverse array of biology ranging at sometimes even from molds to aerobic heterotrophs at the oxygen-depleted water side. Next slide.
Okay, thank you for that, Steve. I'll now be going into a brief case study of one of our brewery projects located here in Australia. This brewery is known as the Coastal Brewery, and it's about 4 hours north of Sydney. Basically, the main drivers for these clients were that they were located nearby an overloaded municipality, and part of the requirements of them installing their brewery operations to begin with was to have on-site wastewater treatment so the local municipality could handle additional loads. As you can see, it's a relatively small-scale brewery known as a craft brewer here in Australia, and their wastewater is only around 900 gallons per day. However, like most food and beverage manufacturers, they are seeking to scale and increase production over the years of their operation, and as a result, BioGill was an ideal solution because it is scalable and modular, capable of growing. Some of the key drivers and necessities for this project were that it was low operation requirements and also controlled odor. This is because the brewers want to do what they do best, making beer. They also have a beer garden where clients come and sit down to taste their products. Consequently, they don't want any smell associated with traditional technologies. If we jump into a brief site layout, you'll get a better understanding of the project. Wastewater is collected in this sump pump station after it has been initially settled and screened, and then passes through a Y strainer. You'll notice that the balance tank is significantly larger than the daily flow currently, however, it is being designed for a 5-year growth period. Here, pH correction occurs and it is passed to a 2-stage BioGill system. These blue boxes indicate the top of the BioGill tower, where wastewater enters the first recirculation tank, passes over the top of the first BioGill tower, and then is gravity fed to the second recirc tank, where it's passed over the top of the second tower. This allows for different biology to grow on each of the units, depending on the level of organic strength that is entering each recirc tank. From here, it is gravity fed to an effluent pump and then can either be discharged to sewer, or in this case, where the client has been told they can only discharge at certain times of the day, to a holding tank. As you can see from this picture, the footprint is quite compact and it is located at the back of their car park. For additional scaling, you simply put an extra BioGill tower at the back of the recirculation tank on this stand, and in many cases, this middle tank or the discharge tank would not be required, and it would be designed to go straight to sewer. It really depends on what the local municipality requires and shows the versatility of the BioGill system. The coastal brewery required to discharge effluent below 600 BOD to meet their trade waste compliant levels. Basically, we designed this system off industry standards with an influent BOD of around 4,000 ppm or milligrams per litre. It has extremely low operation requirements, less than 10 minutes a week, and primarily concerned with ensuring that no solids have passed through the screening and settling process. Other than that, the BioGill units essentially operate themselves. As mentioned a number of times, it's scalable for future growth and does not require large capital expenses up front. Consequently, it's a really cost-effective system for this customer, and again, they can focus on their primary business, which is making beer, and have the peace of mind that the wastewater treatment plant located in their car park is doing what it needs to do. I'll now go into a case study pertaining to an upgrade for a sewage treatment plant that used to utilise an RBC. This is on one of Australia's premier golf courses, Terry Hills Golf and Country Club, located in northern Sydney. Essentially, this client was dealing with ageing infrastructure. They had a rotating biological contactor that was no longer achieving compliance requirements and had a broken drive shaft, so essentially wasn't working at all. It had high maintenance and upkeep costs, and the clients needed to improve their compliance levels or else face fines or shutdown. It's designed to treat around 10,500 gallons per day or 40,000 litres, which is basically a result of the showers and toilets of the clubhouse, the commercial kitchen, as well as a few houses surrounding the golf course. As you can see from this design, we essentially took advantage of the existing infrastructure, which is a major advantage of the BioGill system. Rather than having to go in and redesign and rebuild an entire plant, we simply laid down a concrete slab and installed a number of BioGills next to the RBC tanks. From there, we inserted a number of submersible pumps, as well as a submerged BioGill environment. The design capitalises on the first 2 chambers of the RBC, which act similar to a traditional septic tank. These provide primary sedimentation and anaerobic digestion of volatile solids. Water is then pumped to the cylindrical tank, which contains submerged BioGill media. Water rich in nitrogen oxides is pumped to the same tank, which works as a pre-anoxic stage, where nitrogen oxides produced in the gills are mixed with readily biodegradable BOD in the raw sewage. This pre-anoxic stage is essentially designed for the nitrification process. The standard above ground towers are designed for BOD removal and nitrification. From this, the treated water passes through a clarifier and into a pond where it is used for subsurface irrigation. And as you can see from the results, BOD is less than 10, with soluble BOD being almost undetectable, and total nitrogen is being taken from around 40 milligrams per litre to less than 8. As you can see, Terry Hills has been in compliance for over a year now. The clients are extremely happy, and outside of the specs in terms of meeting the compliance levels, it's actually reduced a lot of odour, which makes the customers more than happy to tee off around the 13th hole, whereas previously they did not look forward to that. I'm now going to pass back over to Steve, who will be talking through one of our high sugar candy manufacturer case studies.
Thanks, Nick. This is the presentation we gave at WEFTEC. The client is a multinational candy company, and as you might expect, such a company has a high sugar, high concentration wastewater, and in this case, they were facing increasing waste discharge fees from the local authority and pressures from that authority to do a pre-treatment program. Thus, the on-site treatment program of BioGill was selected. In addition, on-site treatment to relieve the requirements on the local municipality is one of this company's corporate social responsibility goals. The capacity of the wastewater treatment system is 5,800 gallons per day, and the system designed for that place was 9 BioGill towers. So if I follow the flow rate through here, it's not untypical from any wastewater treatment plant, and the BioGill modules are the secondary treatment process. Let me illustrate here. Influent goes in where the pH into a buffer tank or equalization tank. And that equalization tank is about 3 days of average flow. Then it's recirculated in a tank that's 30 cubic meters and heated, and it goes across the BioGill modules where the aerobic treatment occurs and goes back around in a circle through that place. The BioGill modules, of course, work better when they're warmer, and so the client here installed a solar hot water heater in order to be able to keep the water warm during the winter months. There was a bund, a small collection area in the base of the unit where the BioGill towers are held, and sludge is pumped off into an additional sludge tank. So on this slide, we can see the results. And if you note, the first 5 results were weekly data taken in March of 2015, showing 92 to 71% BOD reduction. It ranges from 2,000 to 3,000 parts per million BOD. From there on, we took monthly data out until January of 2016, and you can see that the performance was consistent from the first month of trials, and the average BOD was somewhere on the order of 80% or greater. The next slide. The result of this project was a 1.5 to 2 year ROI. So from here, I'm going to let Annie talk about Cave Spring Cellars.
Thanks, Steve. Cave Spring Cellars was our first winery project in North America. Cave Spring is a winery located in Ontario, close to Niagara Falls, which produces 60,000 cases of wine per year. Prior to the BioGill project, the wastewater system at the winery consisted only of an open settling tank. The winery incurred costs for frequent pumping and hauling of solids and achieved very little, if any, reduction in soluble BOD. As a result, the winery was paying monthly surcharges based on pretty high concentration of BOD in their effluent that was discharged to sewer. The system also produced a lot of odors, which was unpleasant for staff and visitors to the winery. In 2012, the winery decided to look into ways to improve their on-site wastewater management. They wanted to put in a system that would eliminate surcharges and protect them against future surcharge rate increases. It was also important that the system reduce odor. A number of the options that they looked at were expensive and required significant footprints that would have been difficult and had high construction costs. Some would have involved tearing up their parking lot. Cave Spring was offered the opportunity to pilot BioGill through a partnership with the Bloom Center for Sustainability. The BioGill pilot ran for close to 18 months, demonstrating performance over the complete course of the winery production cycle, in which wastewater flow and loading fluctuate widely between harvest season, bottling, and other activities that change throughout the course of the year. The results of the BioGill pilot convinced the winery to proceed with a full-scale solution designed with 4 BioGill towers. The overall cost of the project was less than 20% of alternative wastewater treatment technologies that they considered. Here on the next slide, you can see some of the design criteria for the full-stage treatment process, which has now been operating for 2 years, since late 2015. Given where the winery is located in Canada, the winters are pretty cold. The modularity and small footprint of the BioGill towers allowed the wastewater system to be located in a basement room below the winery's crush bed. Being able to locate the system here has eliminated the need for any supplemental heating, even during the winter, to maintain high levels of treatment. The system is designed to handle a range in flow and loading to handle the fluctuations in winery activities throughout the year. Overall average influent to the BioGill system is about 3,000 milligrams per liter BOD, and the target effluent is below 300 milligrams per liter BOD, the threshold for high-strength surcharges. Wastewater travels through 2 settling tanks, which remove large solids into insoluble BOD, and then onto an equalization tank and through a basket strainer to remove any remaining large particles. The wastewater then flows to the process tank, which includes pH correction. The Cave Springs project is a batch process design, so water circulates from the process tank over the 4 BioGill towers in a 3,000-minute cycle. Solids that settle to the bottom of the process tank are periodically pumped to a sludge tank, and liquid from the sludge tank is recycled back to the settling tank. The sludge tank is periodically pumped out for solid fouling, which is required less frequently than it had been before. Next slide, please. Results of the system have been very strong. The goal was to eliminate BOD surcharges, and this is something that has been successfully achieved. The system at times even exceeds the 300 milligram per liter target, sometimes reaching levels as low as 100 milligrams per liter BOD in the effluent. The BioGill system has also solved the issue of odors at the facility, improving working conditions for site staff and visitors. Cave Spring has also received a number of accolades as a result of implementing their BioGill wastewater system. In 2016, they became Ontario's first certified sustainable winery. Also in 2016, they were the recipient of the Ontario Premier's Award for Agri-Food Innovation Excellence for the implementation of their new BioGill wastewater system. The winery has also been seen as a role model for other wineries in the region who've come to tour the wastewater system and seek wastewater management advice. Operations Manager Dave Hooper tells us that one of the things he didn't expect was that now people come not only to tour their winery, but also to tour their wastewater system. The BioGill system has brought a lot of positive attention that wasn't necessarily anticipated, and it has built momentum for other sustainability initiatives at the winery. If you're interested in knowing more about this project, we also recently completed a video case story featuring Cave Spring Cellar that's available on YouTube. You can also send me an email at the email address that will be listed at the end of this presentation, and I can send you a link. In summary, major advantages to BioGill are the simplicity of installation, operation, and maintenance. Industrial facilities in particular have their main operations to run, and in most cases do not have the resources for a full-time wastewater operator or a system that requires a lot of daily attention to manage and maintain. BioGill is a proven technology that can achieve very high % reductions in BOD. Data and technical reports are available from our existing installations in over 23 countries. Finally, BioGill's treatment units, both the tower and the new Ultra, are intentionally designed to be modular, allowing systems to be both easy to install and easy to scale to meet evolving treatment needs as facilities expand their operations over time. Next slide. So thanks very much for joining us today. Here on the screen you can see email addresses for our 4 sales contacts in the Americas, APAC, Asia, and China. Please feel free to reach out to any of us for any additional information that you're interested in. We can send that to you straight away.